Okay, so section 4.1 introduced us to exponential functions which have this form y equals ab raised to the x. And what we're going to do in section 4.2 is that we're going to compare these exponential functions to linear functions, which often have this form y equals mx plus b. Okay. We're going to start by looking at the values in a table to see if they could reflect either a linear or exponential function. So in your table, if y is a function of x, which means that x is our independent variable and y is our dependent variable, and this is the really important part that's going to allow you to use this shortcut. So delta x needs to be constant, which means that x changes by the same amount each time. Then we can compare our consecutive y values to see if that table could represent either a linear or exponential function. So if the difference of consecutive y values is constant, so meaning either you add or subtract the same amount each time to get from one y value to the next, the table could represent a linear function. If the ratio of consecutive y values is constant, meaning you either multiply or divide by the same number each time to get to the next y value in the table, then that table could represent an exponential function. So let's try this out with number 1. Determine if the following equations, f and g, could represent a linear or exponential function. It says show work supporting your answers. So let's look at how that is going to play out. So the first thing I want to do, because I'd like to use this shortcut up here, is I want to check these x values out. So delta x is constant here, which will allow me to use that shortcut. So I'm going to make a note saying delta x equals 5 is constant because we're jumping by 5 each time. So then that allows me to just compare consecutive terms rather than finding like the average rate of change or that ratio, which involves a little more calculations. So usually the first thing I start with is I look to see, actually at the end, I subtract. So I go 105 minus 90. So that's a difference of 15. Okay. To get from 75 to 90, we would have added 15. Okay, so this is looking good because I've added the same number both times, right? So I'm going to go through and check and make sure that this is going to hold for all of these. So 60 to 75 is plus 15, 45 to 60 is plus 15, and 30 to 45 is plus 15. Okay, so since I added the same amount each time, that's going to tell me that f of x could be linear. All right, let's try this with g of x. So actually just start on this end here. So the difference to get from 1,000 to 1,200, that's 200. So I would have added 200 here. To get from 1,200 to 1,440, I would have added 240. Okay, so these two are not the same. So I know right off the bat that this cannot be linear because these two are not the same. So I'm going to see if I can figure out what they're multiplying by each time to get there. So I will take that 1,200 and divide by 1,000. Okay, so multiplied by 1.2. So we'll see if that holds for all of these. I'll take 1,440 and divide that by 1,200. So I took the next y term and divided by the previous one. So multiplied by 1.2 again. So that's looking promising. 1728 divided by 1440. So times 1.2. Still that pattern's holding, so that makes me happy. It's promising. 2073.6 divided by 1728 gives me 1.2. And then one last one to look at here, 2488.32 divided by 2073.6 gives me 1.2. All right, so that ratio, and ratio is that fraction, which is what I'm getting by dividing, that ratio is the same all the way across here. So g of x could represent an exponential function. Okay. So on your homework or on a test, I would expect you to note that delta x is what delta x is, and that it's constant in order to just use this trick of comparing these consecutive y values.